Welcome. Rectilinear motion part 17. In the previous lecture we have understood or track a particle because the new series that we have started, that is a particle on track. So this particle on track 2 we are discussing a new thing, but what we have discussed in particle track 1, that if a particle is moving along a straight line, if it is accelerated for some time, then it is retarded and returns to the velocity 0. Then how we analyze the motion? But now we have not discussed this thing. But now in the track 2, particle track 2, I want to discuss the thing that is, if a particle is accelerated for a time, then it is again accelerated for a different value of acceleration. It is not retarded. Let us it is accelerated for the acceleration alpha 1, constant acceleration alpha 1 up to the time t1. Then it is accelerated for the acceleration beta, for the value of acceleration beta up to the time t2. Then how the equations of motions are different? Let us see. So let us consider a particle is here at t equal to 0. Initially its velocity is 0. We have considered, and it is moving along a straight line. Okay, so obviously it holds the rectilinear motions principle. And when t equal to t1, it covers the distance, I say, that is x1. Previously I have considered d1, now I have considered x1, whatever be it I can consider. So let us say it is x1. So when it reaches here, till the time being, it is accelerated by an value alpha. Now after t equal to t1, I made a new addition that the particle now start moving with the value of velocity it achieved here. Let us say the value of velocity it achieved here, that is v. So it is continues with this velocity. We say that is the time t2, and in the meantime it covers the distance x2. From t1 to t2 it covers the distance, that is x2. Okay, so now let us consider, that is, after that again an retardation beta is acting on it. Okay, now there is a slightly change from the previous one. In the previous one, this section is absent there. So let us try to check this type of thing here. I take this type of thing here. So when t equal to t3, it is here. Okay, so and here its velocity obviously v, it is not changed, but when it reaches there, its velocity becomes w, say. Okay, w is the velocity. I can consider this thing. So if I try to calculate the time, 0 is here at t1 is here. When it is t2, then total time with respect to here, we can say it is t2 plus t1. So in covering this interval, this x2 path, it takes the time t2. And here when it reaches, at that time I can say that it takes the time t2 plus t1. What is this t2 plus t1? t2 plus t1 is from the previous. So in reaching from this point to this point, it takes the time t3. So let us mention these points. That is, it is starting from the point capital P. It then reaches Q. After that reaches R. After that it reaches S. So in going from P to Q, it takes the time t1. In going from Q to R, it takes the time t2. In going from R to S, it takes the time t3. So this is the thing. So if I want to execute the velocity versus time graph, I think it is very easy to you, because here just see, when t equal to 0, we can say when t equal to 0, at that time the particle just starts its journey and then it is accelerated, so its velocity increases and it reaches the maximum value, that is I am saying that is v. After that, at time t1 its velocity achieved by it is v. Then it is just moved with the same velocity, no change in velocity, because the slope of the velocity versus time graph, if I draw, it is 0. No acceleration, the velocity remains the constant. Okay, no acceleration, the velocity remains the constant here. Okay, so when it reaches here, that is t1 plus t2, so it runs for the time t2 with the constant velocity, the slope is 0, so the uniform velocity. After that, it again an acceleration, not the retardation, the negative acceleration is acting on it. When it reaches here, it is t1 plus t2 plus t3. When it reaches at this point, it is t3. So it is p, it is q, it is r, it is s. Now I am saying this thing in terms of the velocity. Now you tell me, if this thing happens, can you tell me that is the particle returns to the same point? Obviously no, because it is velocity versus time curve. Maybe the displacement versus time graph, if I want to draw just here, just below it, that will be helpful. Just below it, then it covers the first distance x1. Okay, the distance increases, it is displacement versus time, or if I want to say displacement versus time curve. Okay, after that it's moving the x2 distance. This is I am saying it is the x1, you can say this is the x2 distance. Okay, after that it is again reach the distance x3. Maybe the slope is not like this, maybe the slope is not like this, but it is again moving this direction. So maybe its velocity is less than that of v. So before becoming 0, it obviously moves the distance x3. So the total distance is x1 plus x2 plus x3. So if I want to find out from it, if anyone say prove this, what is the proof? The proof is x2 equal to x minus of v square divided by 2 into 1 by alpha plus 1 by beta. For what? For this scenario that I am representing here, or in the graph that I am representing. Okay, and the total time taken, if I represent this thing by capital T, that is the sum of t1 plus t2 plus t3, and that will be x by v minus of plus of b by 2, 1 by alpha plus 1 by beta. These two things we need to prove. So what we will do basically, just see, for the first case, when it covers the distance x1 with the velocity starting from 0 to capital V, covering distance x, covering distance x1 with the acceleration is there alpha 2. So if I write down the equation here, then we can say that is x1 equal to 0 into t plus 1 by 2 into alpha into t1 square. We can also write down this thing, v square equal to 0 square plus 2 into alpha into x1. Okay, so we can write down this thing for the first, and also we can write down this thing, that again another equation of motion left, that is 0 plus alpha into t1. So these three equation of motions for the first, and if I write down for the second one, that is second event, it is the event 1, and for the second event if I want to write, then x2 equal to v into t, only one equation, because here is no acceleration, so the value of the acceleration is 0, so there is only one equation. Okay, and now after that it is retarded, and this value of retardation is beta, and we can say this is a third event. So this is for the first event, this is for the second event, and now I am writing for the third event. Now if I for the third event, if I write down this thing, that is in the third event the distance covered by it is x3. So x3 into 0 into t3. Here we have to write down this t2, the time taken in the second event is t2, so it is t3 plus 1 by 2, not plus, it can be plus because retardation, so it will be negative. So 1 by 2 into beta into t2 square. After that again another equation we can write, that is 0 square equal to v square minus of 2 beta into x3. Again we can write that v equal to 0, not plus, the final velocity is 0. Initial velocity is v, after that the retardation is beta, and the time is t3. Okay, so these equations 3 plus 3 6, 7 equations we can write. But which equations are important for us? We have to prove the total distance, that is x2. What is x2? What is x? X is basically x1 plus x2 plus x3. What is x1? We can find out the x1 from the first equation, this one or this one. You can find out if it is find out with from this one. Why I am taking this one? Because when I have to prove the x here in terms of velocity is represented, no kind of time is represented there, so I just, for avoiding the time, I just take this equation. So this is also an important conclusion that I want to say, that which equations I have to take, that is also I have to think after the seeing the equation that I have to prove. So it is v square divided by 2 alpha. And what is x2? The x2 is remains as x2 because we have to find out this x2. So I just take this x2 as x2, and it is v square divided by 2 into beta. Okay, so this will become v square divided by 2 into 1 by alpha plus 1 by beta plus x2. So this is equal to this. So if I find out, if I just write down at a time, v square divided by 2, 1 by alpha plus 1 by beta plus x2. We have to find out the value of x2. So x2, if I have to take this term on the left hand side, or whatever be it, if we do the side change, then it will be x v squared by 2, 1 by alpha plus 1 by beta. The first equation we are going to prove, that is this one, is completely proved. Okay, now I am going for the time, capital T, total time. So if I going for the total time, then just see capital T is a sum of 3 times. It is a sum of 3 times. And from here we can get this time. Obviously we can get this time here, but there is a square root, a jugular equation, and but we have to prove this thing. As the velocity is there, no time is here, so I just don't use this equation, nothing else. So if I put the value t1 here, if I put the value of t1, what is t1? Just see, t1 equal to v equal to alpha t1. So t1 equal to v by alpha. So I am just writing down t1 equal to v by alpha. What is t2? t2 equal to x2 by v. t2 equal to x2 by v. So I can write down this thing as x2 by v. x2 by v. Okay. The next is that x2 by v. Now next is this t3. What is t3? I'm just finding out here is t3. So t3 equal to v by beta. Okay. So if I just accumulate these things, that is V, if I take common, it will be 1 by alpha plus 1 by beta. 1 by alpha plus 1 by beta. Now if I 1 by alpha plus 1 by beta, now if I put the value of x to that we have just derived here, it will be 1 by v, it is 1 by v x minus of v square divided by 2, 1 by alpha plus 1 by beta. Okay, 1 by alpha plus 1 by beta. So this is the thing. So it is v into 1 by alpha plus 1 by beta. I just left is as it is. So if I do the multiplication, it is x by v. If I do the multiplication, it will be v by 2, 1 by alpha plus 1 by beta. So just see here. So if I just subtract this term and this term, just see. If I just do it, then it will be v by 2 into 1 by alpha plus 1 by beta plus x by v. Okay, so what I am going to prove here, the total time equal to this equation. Just see, this is the equation that I am going to prove for time, and this is the equation I am going to prove for the time interval, sorry, the distance which is covered by the particle when it is moving with the uniform velocity. So this thing I am going to say, this type of things basically comes as a proof. One thing I want to clarify here from the graphs, that here the graph which is the velocity versus time graph, this is also the speed versus time graph, because the speed and the velocity is moving in the same directions, no direction is changed, so the magnitude of the speed and the magnitude of velocity is same. So there will be no change here, and obviously in case of S versus T graph, that is I am basically calling the displacement versus time graph, this displacement versus time graph also remain the same. If I represent the distance versus time graph, no nature change is there, because here the particle is moving along the particular line or along a certain directions. Now I am going to tell you how these problems can become in your exam. Maybe it is said there are two stations at capital A and capital B. Okay, just think, there are two stations from capital A and capital B. A train starts from capital A, it accelerates itself, after that moving with a constant velocity for some time, crossing the maximum distance, and after that it returning, applying the brake, and ceases its motion when it just entering the station B. So this type of things can be applied in case of train, because here obviously where I have considered that the train track is straight. Not only the train, if I consider about a car, it is moving a highway, it just starts its accelerator, it just starts its motion from rest, and after that it is just increasing in speed, attains the maximum speed it can go, and with this maximum speed it goes for a longer distance it can cover. After that it just pushes the brake and just reaching the aim or the position it want to reach. So this type of problems can come in your exam with also with the numerical values. Sometimes the numerical values are given from the graphs. Just like here it is said that the acceleration's value is given, sometimes that retardation values are given, sometimes it is said that up to which that I find out if it is runs for this time interval. Just think about this, if it is runs for this time interval, find out the total time interval. If we cover the total distance in the odometer, and if you know the maximum velocity attained by it, and if you know the acceleration retardation. So several types of problems can come, so you have to deal with that tactically, because you know the basic concepts now. Maybe here in case of alphabet A they use A and B, in case of x1, x2, x3 they use d1, d2, d3, its total time they use tau or something. I am telling all of these things now because this may create the problem. This actually creates a problem. When you see this equation in different notations, it basically creates a problem, so that we can choose the options from several options. Choose the correct options from the several options. Thank you.